time. What is transmission time? So we don't send the bits just we don't just send the single bit, but we will send as a message. So the first bit may take a time equal to the propagation time to reach its destination. The last bit also may take the same amount of time. However, there is a time between the first bit leaving the sender and the last bit arriving at the receiver. So the first bit may be due to various factors. The first bit leaves earlier and arrives earlier. The last bit leaves later and arrives later. So the transmission time of message depends on the size of the message and the bandwidth of the channel. So that is calculated as transmission time equal to message size divided by bandwidth. So let us see an example here. What are the propagation time and transmission time of 2.5 kilobyte message? So it may be an email with a bandwidth of network is 1 Gbps. So assume that the distance between the sender and the receiver is 12,000 kilometers and that the light travels at 2.4 into 10 to the power of 8, sorry, that is 10 to the power of 8 meters per second. So in that case, if we calculate the propagation and transmission time, propagation time is distance by speed, so that is 50 millisecond as we saw in the previous example. Now the transmission time is calculated by the formula message size by bandwidth. So what is the message size? So message size is 2.5 kilobyte, that is 2500 into 8 bits divided by the bandwidth. So the bandwidth is 1 Gbps, that is 10 to the power of 9. So when you divide, you get 0.020 milliseconds. So this is the transmission time, which is going to be the delay, the distance or the time taken for the first bit and the last bit. So the first bit, the time taken between the first bit leaving the sender and the last bit arriving at the receiver. So it is a meager time anyway, that has to be calculated. So in this case, because the message is short and the bandwidth is high, the dominant factor is the propagation time, not the transmission time. The transmission time can be ignored in such cases, but in all the cases it won't be so. Here in this example, what are the propagation and transmission time? 5 megabyte message, and if the bandwidth is 1 Mbps, assume that the distance is 12,000 kilometer as usual, and the time light traveling time is 2.4 into 10 to the power of 8 minutes per second in case of fiber optic transmission being considered. So propagation time is 12,000 into 1000 meters divided by 2.4 into 10 to the power of 8, that is 50 millisecond, and transmission time is, so 50 megabytes converted into bytes into 8 divided by 10 to the power of 6, so it comes as 40 milliseconds. Compared to the previous one, here the transmission time is higher. So note that in this case, because the message is very long and the bandwidth is not very high, the dominant factor is transmission time, not the propagation time. So here the propagation time can be ignored. So it can be included or it can be ignored. That is our choice. So now the third factor in calculation of latency is queuing time. And what is queuing time? So we may have the time needed for each intermediate or end device to hold the message before it can be processed. So it's not a fixed factor, it changes with the load imposed on the network. When there is heavy traffic on the network, the queuing time increases, and an intermediate device such as router queues the arrived messages and processes them one by one. So it's the bottleneck, and there are many messages, then each message will have to wait. So this is queuing time. And bandwidth and delay are two performance metrics of a link. And what is very important in data communication is the product of the two, the bandwidth delay product. So the bandwidth delay product defines the number of bits that can fill the link. So for example, in case 1, the bandwidth is 1 bits per second and delay is 5 seconds. So in that case, you can see after 1 second 1 bit is sent, after 2 seconds 2 bit is sent, and so on. So totally the maximum capacity or volume of bits which can be sent through the link is bandwidth into delay equal to 5 bits. So in case 2, bandwidth is 5 bits per second. So in that case 5 bits are sent at a time and delay is 5 seconds. So in that case we are able to send 5 bits. So totally bandwidth into delay is 25 bits. So bandwidth delay product can be considered as a link between 2 points, like a pipe, and the cross section of the pipe is bandwidth and the length of the pipe may be delay. So we can say the volume of pipe is defined as the bandwidth delay product. This is the concept of bandwidth delay product, which can be considered for the performance of the network. And we also have jitter. So jitter is another performance issue which we have in case of communication in physical layer. So it is a problem if different packets of data encounter different delays and the application using the data at the receiver side is time sensitive, like audio or video data being streamed live. So if the delay for the first packet is 20 millisecond and second is 45, third is 40, then the real time application that uses the packet induce a jitter. So this is also another performance factor. So these are the various things which I wanted to discuss regarding physical layer performance. Thank you.